Okay, so the only thing that I want to go over with you is how to set up equations for functions for the word problems. So we're going to go through this quickly, so it shouldn't take too long. The first example is from the paying it forward. So remember, the idea was that each person does 3 good deeds and those 3 people do more good deeds, or each person does 3 good deeds for somebody else. So here's a problem for you. So you and 5 of your friends watch the movie Paid Forward and get inspired by the idea. So you're going to follow the idea described in the movie. Write a function that would represent the number of good deeds. Okay, so first of all, hopefully we realize that this is an exponential growth because we are increasing the number of good deeds. So the function is going to be the starting value. So if it is you and 5 of your friends, there are 6 people that watch this movie, so there's 6 to begin with. And then since each person is going to do 3 good deeds, our growth rate is going to be 3 to the power of x. So this would be the function. So 6 times 3 to the power of x. Here's another problem for us. It's a car depreciation problem. So Mrs. Pinova purchased a brand new Honda Fit for $16,000. Each year, the car will lose 11% of its value. Write a function that represents the value of the car over time. So this needs an S here. Okay, that would represent, so we don't need an S. Just kidding. Okay, so before we do anything else, I want to just think about the percents and how they work. So look. We start with 100% of something, right? So we're going to lose 11% of the value. So if I'm going to lose 11%, now I will end up with 89%. And then I'm going to lose 11% of that. So to get from 100 to 89%, what's going to happen is we're going to multiply by 0.89. So that's going to be your decay rate. So in this case, we are actually losing value, so that's why it's an exponential decay. So the function is going to be my starting value, which is $16,000, times 0.89 to the power of x. In this word problem, we have $500 that you got for your birthday, and you decided to put it in a savings account that will earn 44% annual interest compounded yearly. Just means that at the end of each year, you get 4% on top of your investment. So first you have 100%, right? So that's your $500. And then you're going to get extra 4%. So you're going to get 104%. So what would we have to multiply by if we go from 100 to 104? We're going to multiply by 1.04. So remember that 1.04 would represent the $104. I mean 104%. So 1.04 represents 104%. Okay, so my function is going to be my starting value, so 500 times 1.04 to the power of x. So 1 year later, if you want to know how much money you have, you would replace x with 1. If you want to know 5 years later how much money you have, you would replace it with 5. Here's another one. I think this is the last one. So you have an equilateral triangle with an area of 1. So you have this triangle and the area is 1. You will fold it so that each corner, so this corner gets folded this way, and this corner gets folded this way, and this corner gets folded this way. So just to give you an idea, so what's going to happen is it's going to look like this tiny triangle inside once we actually fold it. So let's think about this. What's our new area? Well, our big triangle had an area of 1, and if you, hopefully you could see that now we have 4 equal parts, and my actual area is only one of them. So this is going to be 1/4. And if I fold it again, it's going to be 1/4 of this area. So this is an example of exponential decay because we're actually, the number is going down, and my decay rate is 1/4, because if I went from 1 to 1/4, I multiply by 1/4. So a function that represents the area. So my initial value is 1 because that's the area of my first triangle that has 0 folds. And then my decay rate is 1/4 to the power of x. So what I wanted to do is I wanted to show you something that you'll see in our book, which could be helpful, is there's a specific formula for exponential growth if you're dealing with percents. So for example, you had your bank investment problem. So you had $500 and it grew 4% yearly. So basically, it's exactly what we did, but it just tells you that your rate here, so if it's 4%, is actually 0.04. So it's the 4% that gets added to 100%. So basically, if you follow this formula, it's telling you that to get your function, you would take your initial amount, and then you would do 1 plus 0.04 to the t for the time period, or you can use x, which would be 500 times 1.04. So this is exactly the same equation or function that we had. We just thought about it as starting with 100% and adding 4% to it and ending up with 104%, which is how we got this number. But you can also break it up and think of it as 1 plus 0.04%. Now this is exactly the same formula. The only difference, instead of plus, it's a minus, because now we are reducing the amount. So this was our car depreciation. So our car depreciation was, so the starting value was $16,000, and the car lost 11% each year. So this would be the decay rate, and it would really be 0.11 because that's what it is for percent. So you would do 16,000 times 1 minus 0.11 to the t as a power. So it'll be 16,000 times 0.89 to the t. So this is exactly the same thing that we had, this is just using the formula. And we'll talk more in class on when I see you, but and we'll talk about which one you think is easier, whether the formula or just thinking about it is easier for you. But I wanted to make sure that you're familiar with both. So you can either use the formula when it comes to percent growth or percent decay, or you could just think about what the growth factor is going to be.